Today we're going to learn about converting repeating decimals to fractions. In previous lessons, we talked about converting decimals to fractions, but they were not repeating. So we'll start with our first example. As you'll notice, we have a bar over the 5. That means it's actually repeating. So we could rewrite it as 0.55 as long as we wanted to go repeating. That's what's happening. So we have to write this as a fraction. In repeating fractions, we cannot just look at the place value and say it's in the tenths and write it as 5/10. That's incorrect. That would be as a half. And even though this would be a half without the repeating sign, this has a repeating, so it's not a half. So we're going to use a strategy here, and then I'm going to show you a shortcut for this strategy, but we're going to talk about why this works and how it works first. So the first thing we're going to do is we're going to call what this is, this as we wrote it, repeating out, we're going to call it x. So we're going to say x is 0.5555 repeating. Okay? Now, I want to get it to where I can cancel out or get rid of the repeating part. So I know that if I move my decimal place one place over, I have to multiply by 10. So that means if I multiply this by 10 times x, I end up with 5.5555 and so forth repeating. Now, once I get that to a situation where I can have two equations, I'm actually going to combine those two equations by subtracting. I'm going to take the second equation that I made. This was the second one. I'll put two little i's there. And this was the first one. I'm going to take my first one and subtract from my second one. And I end up with 10x minus x gives me 9x. And notice here, all of this cancels out and I'm left with just 5. So now I have a very simple equation. I'm now going to solve for x because I want to know what x would be, what I'm writing as a fraction. So divide by 9, x equals 5/9. So this is what it would be if I wrote 5 repeating as a fraction is 5/9. So start paying attention to what's happening here when it's repeating with just one place. I actually put a 9 on the bottom. Let's go on to example B. So at this one we have 45, and then 45 total is repeating. So we're going to look at how can we write this as x. So we're going to write x is 0.454545 and so on. It would go on forever. And then I need to write it so that I can get where the 4/5 would cancel. So that end part of my decimal would cancel. Well, I need to move it 2 spots because 2 places are repeating. So when I move it 2, I'm actually multiplying by 100. So I'm doing times 100. So I end up with 100x is equal to 45.454545 and so on. And now I'm going to subtract those two. 100x minus x gives me 99x is equal to, this side all cancels out, and I have just 45 minus 0 is 45. Now I'm going to solve for x. Divide by 99, and I have x is equal to 45/99. And this is my fraction. Now I have to look, can I simplify this further? Is anything that can go into this the same amount of times? Well, it's actually divisible by 9. 45 divided by 9 is 5. 9 divided by 9 is 11. So this is the same as 45 hundredths repeating. All right, example C. On this one, we have only one of the numbers is repeating. You'll notice the bar is just over the 9. So we're still going to do the same thing, but we have to get our x. Right now, what we call our x would be x is equal to 0.49999. Well, we want to get it where the decimals after the decimal point all cancel. Well, we have to get it to move over. So we're going to actually move our decimal one place, and let's see what happens. So one place is doing 10x, because we've moved it one time, so that's times 10. This brings you back to scientific notation. And I end up with 4.999, etc. Well, I can't use these together because these after the decimal point are not the same. I still have a 4 there. So I need to make another equation that will work. So I did 10. Well, what if I go over 2 spots? 1, 2. That would be 100x is equal to 49.999, etc. So now if I look, these two equations actually have the same thing after the decimal, and they would cancel out if I set them up to subtract from each other. Well, I'm going to take the bigger one, 100x, which is equal to 49.999, etc. And I'm going to take away the 10x equals 4.999, etc. 100 minus 10 gives me 90x. This side all cancels out, and 49 minus 4 gives me 45. Now I solve for x. Divided by 90, divided by 90. I have x equals 45 over 90. Well, I'm going to look and say, okay, can this go any simpler? Well, this can be divided by 45. So divided by 45, divided by 45, I end up with 1/2. Okay, so even though this 0.49 repeating does not look like 1/2 when we started, it actually is 1/2 when we get simplified all the way down. Now we're going to go to one that is repeating with 9/4. However, the rest of it, the 2/3, is not repeating. So we're going to do the same thing. Our x first is called 0.239494, and so on. Well, we want to get this decimal to move over so that just the repeating part is after the decimal. So if we think about what we're doing here, is we moved this one over 2 spots. So 2 spots is 100x. 100x is equal to 23.9494, etc. Now we have to come up with another piece that we can move over to get it enough to subtract out. Well, we went by 100, and going by 10 would only get us 2.39, and the recurring decimal part would not be the same. And if we did 1,000, this would be 1, 2, 3. Then we'd have 4949, and that's not the same as 9494. So we have to go to 10,000. So 10,000x. So that means we're going 4 places over. So let me change my color here. So 4 places. 1, 2, 3, 4. And then our recurring part would be repeating. So this 10,000x would be equal to 2394, 94, keep putting 99, 94, 94, etc. Now these have the same repeating or recurring part after the decimal that will cancel out when we put them together. So we're going to call this equation 1, and we'll call this one 2. And we have to subtract the smallest one, which was equation 1, from the largest one. So I'm just going to move him down here. So we have 100x and 23.9494, etc. And now we're going to subtract. So these cancel out. And then 2394 minus 23. 4 minus 3 gives us 1. 9 minus 2 gives us 7. And then we have nothing here, so 23. And then equals 10,000 minus 100x. We're going to get we would have 9900x, and then we would divide by that to find out what x is on both sides. So we have x is equal to 2371 over 9900. So we'd look to see if we could simplify it. Now, the whole point of what we're doing is we're trying to make two equations so that we can have the recurring part, the decimal that keeps going on, to cancel out. So that's why we're making two equations. So we're going to go to the next examples, and we're going to show you some shortcut ways to do this between simple and mixed numbers. So here are 4 examples. We have 0.3 repeating, 0.75, which is the 5 repeating, 0.352 with the whole thing repeating, and then 0.2394, which is the 94 repeating. And underneath I've put some words. These are simple, the ones that have all the numbers in the decimal repeating. So you'll notice for the first and the third example, everything that is written is repeating. Whereas in the second and fourth example, only part of the decimal is repeating. So we're going to start with the simple ones. So this is a simple shortcut technique. When you start seeing the patterns, it'll make more sense to you. So we're going to think about what our denominator is going to be. So in our very first one, 0.3 repeating, we're going to put as many 9s in the decimal as there are places. So if we look at our problem here, and I have just one spot, I'm going to put a 9 in my denominator. Then I'm going to put my 3, whatever number is repeating, here in the top. And then I'm going to simplify. Can 3/9 be simplified? Well, yes, it's supposed to be divisible by 3. So I end up with 1/3. So 1/3 is the same as 0.3 repeating. Now let's do example 3. I'm going to put as many 9s in the denominator as I have repeating symbols. So I have 1, 2, 3. So I'm going to put 9, 9, 9. Then I'm going to write what I have. 3, 5, 2. And then I'm going to see, can I simplify? And I can't simplify any further. So now let's go to the mixed one, example 2. I'm going to put 9 in the denominator of how many I have recurring. Well, I only have 1. So I'm going to put 9 here. But I have more numbers that aren't recurring. So for every number that I have that is not recurring, I add a 0. Now I'm going to write the number that I have originally, 75. And I'm going to look at the number that's not recurring, and that is 7. So I'm going to take that number away from 75. So 75 minus 7 gives me 68/90. Then I would look to see if I could simplify it further, which you should be able to do. So then I go ahead and let's look at the fourth example. I have 2 numbers that are part of the repeating part. So I'm going to write 99. And then I have 2 digits that are not repeating. So I add 2 zeros. Then I'm going to write the number that I had originally, 2394. And I'm going to take away from that the numbers that are not repeating. So minus 23. 2394 minus 23 gives me 2371 over 9900. And I would look to see if it can be simplified further. All right, so let's go back and do a couple of the ones we did previously with our shortcut method. So this is example A again. So as using our shortcut form, we look and see how many places do we have that's repeating. We put that many 9s. So we have a 9. Then we write our number over top. And we can't simplify any further, 5/9. So the same thing we got the very first time, took a lot less time. So now that we understand kind of what's happening, using the shortcut method is much more time sensitive and doesn't take as much time. Don't worry about the rules. Once you understand what's happening, you know how to do it. So now let's look at our example B. We put how many ever repeating pieces in this part. Our repeating's over 4 and 5, so that means we have 2 repeating pieces, so we put 99 and then 45 on top, and then we would look to see, can we simplify it down? 9 can go into both, so we would divide by 9. Divide by 9, we would get 5/11ths. Same as we got before, much faster. Now, C, we had just one piece repeating, so we put just 1 9. And then we had one piece that's not repeating, so we add a 0. Then we write 49. That's what the whole thing was there. And then we take away the amount that was not repeating. So we get 45/90. And then we would simplify it down. Divide by 45. Divide by 45. We would get 1/2. Now, we're going to talk about doing some with mixed numbers. So sometimes you have a whole number before the decimal and then something repeating. So we're going to think about what this is. This is actually a 2 plus a 0.3 repeating. Well, we're going to leave the 2 alone. We know how to use and change this one. This repeating is 9, so it's just one place repeating. And we put the 3 over top, and we simplify it down to 1/3. And then we got to add back the 2. So this is the same thing as 2 and 1/3. Or we can write it as improper. 3 times 2 is 6, plus 1 is 7, 7/3. Those are both equivalent. All right, let's try this last one. We have a 4 plus 0.5 with the 5 repeating. We'll leave 4 alone. We're going to look at just how to do the repeating. Well, there's one digit that's repeating, so we put 1 9, and one digit that's not repeating, so we add a 0. We write then what is given, 55, and we take away the piece that was not repeating. So we end up with 50/90. Can we simplify? Well, we can start very simple. We can divide by 10. Divide by 10, we end up with 5/9. Hopefully you could see, and you could always mark those 2 zeros out. We'd end up with 5/9, and we add it with our 4. So we have 4 plus 5/9, which is the same as 4 and 5/9. Or we can simplify it to improper and put it as an improper fraction. All right, you have some practice. Do your best.